Now, let's talk about the form of an exponential function for complex numbers. We know that our exponential function has the z now, or z, which stands for any complex number, let's say x plus iy or yi, would be the exponent now. So the exponential function is actually written in this manner. So it's defined rather in this manner. If we have here w as an exponential form, okay, let's say it is equal to e to the power of z. Okay, so our z is the exponent now. Or of course, you can write it as f of z being equal to e to the power of z. And since there's also other forms for this, since our z is expressed in this manner, so we can actually write this as well as e to the power of x plus iy. Okay, that's x plus iy. Now, there are of course other notations to be used here. I might not be able to provide here the proof for this, but basically the other form for an exponential function is actually defined in this manner: e to the power of x, being x is your component for your real part and y is the coefficient of your imaginary part. This is actually e to the power of x times cosine y plus I sine y. This is also the other form of the exponential function e to the power of z. Again, I might not be able to provide the proof for this here. We might have a video later on discussing this. So this is on the form of exponential function, and of course for our z, it can take any complex number form, or even has another scalar quantity for that. The point here is, if we're going to provide some discussions later on that would use exponential function, it's still possible for complex numbers, and it's actually written in this manner. In the next two videos, we're going to prove some important concepts with regards to the exponential function. We're going to show that the, what they call this one, the multiplication law of exponents and the division law of exponents still works for complex numbers. So we're going to have the next two videos to prove that, and we're going to use this component in proving such. Okay, so in the first of the next video, we're going to show, okay, the first one, that e to the power of z sub 1 times e to the power of z sub 2 having the same basis can be written as e to the power of the sum of the complex numbers. Again, we're going to show the proof of that on the next video. And the second one is of course for the quotient, or the quotient of 2. We have e to the power of z sub 1 over e to the power of z sub 2 can be written as e to the power of z sub 1 minus z sub 2. Again, the proof for this will be presented in the next video. Thank you very much for watching.